Hello, welcome to the video. In this lesson, we're going to be looking at section 8.2, where we're going to be analyzing arithmetic sequences and series. So what we are going to do here is we are going to attempt to recognize a sequence as arithmetic. And then once we recognize that a sequence is arithmetic, there is a certain formula that allows us to write a rule for that particular sequence. Now, for a sequence to be arithmetic, it must have a common difference, which means that if you take, let's say you take the second term in the sequence and subtract it by the first term, you would get a common difference. And in this case, if I took -2 minus -9, I would get a value of 7. For this to be arithmetic, 5 subtracted by -2 would have to be 7 as well. And in fact, it is. And it would have to be the same. 12 minus 5 is 7. 19 minus 12 is 7. By having a common difference that is the exact same number, we can say that this particular sequence is arithmetic. So since every single common difference is 7, I can say yes to part A being arithmetic. Looking at B, if I took the differences between 15 and 23, I would get -8. If I took the differences between 9 and 15, I would get -6. Since these two are not the same value, this sequence is not arithmetic. So here, same thing, we have a series of terms for these different problems. Again, uh, I would advise you to check these to see if they are arithmetic or not. If you are not sure, please leave a comment. I am more than happy to um, show you those problems if need be. Now, once you have determined that a sequence is arithmetic, we have what we have here is a way to write a rule for a particular arithmetic sequence, and it is going to show up here. It is going to be whatever a sub 1 is plus n minus 1 times it by d. D is going to be our common difference. So whatever that is, so like when we looked at the very first example, all of those common differences were 7. That means D in that case would then be 7. So here they're asking us to write a rule for the nth term of the sequence. Then they want us to find a sub 15. So first off, we got to find the common difference. So if I took 8 minus 3 is 5, I'm just double checking 13 minus 8 is 5, and 18 minus 13 is 5. So that leads me to believe that my common difference is 5. So going back to using the formula, a sub n equals a sub 1 plus n minus 1 times it by d. Well, I know what a sub 1 is, that's 3, plus n minus 1 times it by 5. So here, I can distribute the 5s. Now I get 3 plus 5n minus 5, combining like terms, and I'm just going to rewrite it in standard form. So my rule for a sub n is going to be 5n minus 2. And then here, they're asking you to find a sub 15. Well, you're just going to take 5 times it by 15, subtract it by 2. 5 times 15 is 75, minus 2 is 73, so a sub 15 is 73. If we were to look at part B here, looking at the common difference, so 47 minus 55 is negative 8. Double checking, 39 minus 47 is negative 8. And 31 minus 39 would be negative 8 as well. So looking at a sub n, I have my a sub 1, which is 55, plus n minus 1 times it by d, which my common difference is negative 8. So distributing that negative 8, so now it's going to be 55 minus 8n plus 8. So combining like terms, my a sub n rule is going to be negative 8n plus 63. To find a sub 15, same thing, take negative 8 times it by 15, and then you're going to add it by 63. Negative 8 times 15 is negative 120 plus 63 is negative 57. Okay, so now here, they're telling you that says one term of an arithmetic sequence is a sub 19 is equal to negative 45. They're telling you that the common difference is negative 3. They want us to write a rule for the nth term, and then it says then graph the first 6 terms of the sequence. All right, I'm not worried about graphing, but we will find the first 6 terms of the sequence. So to write a rule on this, we need to figure out what a sub 1 is. All right. So to figure out what a sub 1 is, what we're going to do is we're going to use a sub 19 to help us figure out what a sub 1 is. So a sub 19 is going to be equal to a sub 1 plus 19 minus 1, which is 18. And then they also tell you that the common difference is negative 3. Well, what we're going to do now here is we're going to substitute a sub 19 with what it equals. Well, it equals negative 45. So it's going to be negative 45 is equal to a sub 1, and it's going to be minus, because it's going to be 18 times by the negative 3, so it's going to be the minus 54. So what this does is this allows us to determine what a sub 1 is. So add 54 to both sides, so negative 45 plus 54 is 9. So 9 is a sub 1. So now we have enough information to write our rule for a sub n. So a sub n is going to be equal to a sub 1, which is 9, plus n minus 1 times it by d, which they tell you is negative 3. When you distribute the negative 3, I get 9 minus 3n plus 3. So my a sub n rule is going to be negative 3n plus 12. All right, so that's my rule. And then the first 6 terms of the sequence is going to be 9, because that's my a sub 1. And next is going to be 6. Then it's going to be 3, 0, negative 3, and negative 6. So those are my um, first 6 terms of the sequence. Here, they're asking us, they're giving us 2 terms of an arithmetic sequence. From here, they want us to write a rule for the nth term, okay? So, looking at this, a sub n is equal to a sub 1 plus n minus 1 times it by d. Our unknowns in this case is I don't know what a sub 1 is, and I don't know what my common difference d is. So since I have 2 unknowns, I need 2 equations. Luckily, they give us 2 terms, so we can use 2 equations. So I'm going to rewrite it with the rule with respect to a sub 7. So a sub 7 is going to become looking like this with the setup of a sub n. It's going to be 17 is going to be equal to a sub 1, which we don't know what that is yet, plus 7 minus 1, which is 6, times it by d. I don't know what my common difference is, so that's all I can write. If I look at this term determine the sequence, I can rewrite this with respect to the rule is 93 is equal to a sub 1 plus 26 minus 1 is 25, so I got 25d. All right, so I got two unknowns. I have two equations to help me solve it. So what I'm going to do is I'm just going to rewrite here. So I got the 17 equals a sub 1 plus 6d. All right, since a sub 1s are, basically the same term, I'm just going to try to eliminate a sub 1. So I'm going to put minus, minus, minus across the bottom. This cancels out using systems. 25 minus 6 is 19, so they got 19d over here. And then 93 minus 17 is 76. So 76 divided by 19, I get d is 4. All right, now that I know that d is 4, what I can do is come over here and say, oh, now I can say that 17 is going to be equal to a sub 1 plus 6 times 4, which is 24. Take 17 minus 24. Oh, negative 7 is now a sub 1. Now that I know what a sub 1 is, I know what my common difference is, I have all the information to write my rule for a sub n. So a sub n is now going to be equal to negative 7 plus n minus 1 times it by 4. When I distribute the 4, I get negative 7 is, nope, it's going to be what? Plus 4n minus 4. So my rule is going to be 4n minus 11. So 4n minus 11 is my rule. Looking at an arithmetic sequence, or sorry, excuse me, an arithmetic series that has a finite series, which means it has a stopping point, you can use a formula to determine what the sum of the series is going to be. So if you know how many terms the series actually has, you can use this formula, and it's going to be equal to n. So how many whatever numbers is in the series is going to be multiplied by whatever a sub 1 is plus whatever the last value is divided by 2. So with that being said, if you have a finite series, let's redo because it ends at the 20th term, we can set this up as s of 20, which is going to be equal to 20, because that's n, times it by the quantity of a sub 1. So if I put 3 times, uh, 3 times 1 is 3, 3 plus 7 is 10, so I put 10 over here, plus, with respect to 20, so 3 times 20 is 60, plus 7 is 67, and that's going to be divided by 2. So do all the math here. 10 plus 67 is what, 77? 77 divided by 2, and then multiply it by 20. You're going to get a sum of 770 as our series sum. Final example here, it says you are making a house of cards similar to the one shown. They're asking you to write a rule for the number of cards in nth rows when the top row is row 1. So like this row 1 here shows up as, looks like you're using 1, 2, 3 cards. Okay. Oops. So they want you to write a rule. So looking at it like this, so the first row is 3 cards. The second row, it looks like you're using 1, 2, 3, 4, 5, 6. So it looks like you got 6. And then row 3 looks like you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So you got 9. So is there a common difference? Yeah, if you subtract them, you get 3. Subtract them here, you get 3. So my common difference is 3. So to write a rule for this, you got a sub n is equal to a sub 1, which is 3, plus n minus 1 times it by 3. So, I'll go over here. This is going to be 3 plus 3n minus 3. These two cancel out, so my rule is going to be 3n. The final question here, it says, how many cards do you need to make a house of cards with 12 rows? So this question here is you're trying to add up all the cards in 12 rows. So this is a sum. So you're trying to find the series of 12 rows. So this is using that formula that we just had. So this is n is 12, and it's going to be times it by a sub 1, which is 3, plus, if you look here with uh, 12, I just take 3 times 12, which is the rule. That's 36. So I got 36 here divided by 2. 33 plus 36 divided by 2 times it by 12 gives me a result of 243 cards. And that is being able to analyze arithmetic sequences and series. Hope this helps. Till next time.